Good morning, seventh graders. It's me, Mr. Stark. It is Thursday morning, and I'm just getting things ready for you for the day. We have today we're going to do some work with the scientific method components, the identification of the parts of the scientific method, and I am going to start you with the salamander experiment, and then we're going to try and go through and identify the different parts of the scientific method, which are we will be looking at the problem, identify the problem that's trying to be solved, the hypothesis or the educated guess as to what you think the answer is. We'll look at the experiment, we'll look at the data and analyze the data, and then we'll draw a conclusion, whether the experiment worked or not. And then finally, we'll look at controls and variables. Controls are things that are kept the same in the experiment, and variables are things that are different. And so in the notes that I gave you earlier, the controls were the cars, the make and model of the cars, and then the variable was the independent variable was the color of the car and what that had influence on the on the changing of the temperature inside the car, the rate at which the temperature changed inside the car. The rate at which the temperature changed inside the car, that was the dependent variable, and then the color of the car is the independent variable. So let's take a look at the salamander experiment. Let's run through that, and I'll pull that up here. So a scientist was interested in acid rain. She wanted to know if it had an effect on the salamander development. After studying normal salamander development and the characteristics of the areas affected by acid rain, she came up with a statement. Salamanders that develop under acid rain conditions show a greater number of developmental abnormalities than salamanders that develop in unpolluted water. She decided to test the statement with an experiment. She raised 1,000 salamander eggs in water with normal acidity. She raised a different group of 1,000 salamander eggs in water with high acidity. This represented the polluted water. She took careful records of the salamander's development. She found that 6 of the 1,000 raised in normal water were abnormal, and 440 of the 1,000 eggs raised in polluted water were abnormal. She concluded that more salamanders developed abnormally in acidic water. So now I'm going to switch over to hopefully have you look at the key to this, which I've posted on Google Classroom. Okay, so we have the same scenario here. We have identification of the problem. Okay, the problem is right here. She wanted to know if it had an effect on the salamander development, if acid rain affected it. Okay, so then she had a hypothesis. She developed a hypothesis that said that the hypothesis is the educated guess. She said that salamanders that develop under acid rain conditions show a greater number of developmental abnormalities than salamanders that develop in unpolluted water. So that was her hypothesis. Her experiment and materials were to raise 2 sets of 1,000 salamander eggs, one in normal water and one in high acidity water or polluted water. Okay. Her conclusion was that the salamanders that developed in the acid water had more abnormalities. And then we'll look at the controls. What stayed the same? Okay, the number of eggs stayed the same, 1,000 and 1,000, and salamander eggs were the same. What was she testing? What was the independent variable? She was testing to see if the acidity had an effect. So that's the one that she changed, that the tester changed to see if it had an effect on the development of the salamander eggs. So the independent variable was the acid water. The dependent variable was is what you are trying to measure. Okay, so the dependent variable in this case was the development of the salamander eggs. And remember that the independent variable will cause a change in the dependent variable. So the acid will cause a change in the development of the salamander eggs, whether they're abnormal or not. So that's what you're measuring is the number of abnormal eggs. So in this case, the 440 of the 1,000 eggs was raised in polluted water were abnormal. That's our dependent variable. That's what we were measuring. So again, just to run this through here, our problem was does the acid rain have an effect on salamander development? Her hypothesis was that she thinks that acid rain will cause more developmental abnormalities. Our experiment was to raise two groups of salamanders, 1,000 salamander eggs, one in normal water, one in acid water. Our data was 6 of the eggs raised in normal water were abnormal, and then 440 of the 1,000 eggs raised in the polluted water were abnormal. That's our data. Our conclusion was that the acid pollution has a greater effect on the development of the salamanders. Okay, it will affect the salamander abnormalities at a higher rate. Our control was things that we kept the same. That would be the number of eggs. And then our variable independent was, what are we testing? We're testing the acidity. And then dependent variable is what's affected by that acidity. And that's the number of polluted or abnormal eggs that developed in the polluted water. So that was just an example of how to identify the parts of the scientific method. There's nothing to do on that part of that. It was just kind of me walking you through that, giving the example. I'm going to walk you through the first part of your assignment today. Okay, so we have 4 little scenarios, and you have to identify certain things. So Mr. Krabs wants to Patty Power. Mr. Krabs wants to make Bikini Bottom a nicer place to live. He's created a new sauce that he thinks will reduce the production of body gas, farts, with eating Krabby Patties from the Krusty Krab. He recruits 100 customers with a history of gas problems. He has 50 of them, Group A, eat Krabby Patties with the new sauce. The other 50, Group B, eat the Krabby Patties with the sauce that looks like the new sauce, but is really just mayo and food coloring. Both groups were told they were eating the sauce that would reduce gas production. 2 hours after eating the Krabby Patties, 30 customers in Group A, that is the one that ate the new sauce, reported having fewer gas problems. And 8 customers in Group B, that's the one that got the mayo and food coloring, reporting having fewer gas problems. So now we're looking to identify the control. What stayed the same? What didn't change? That would be the group B, the mayo and food coloring group. They did nothing changed there. They're using that to compare the new sauce to. What's the independent variable? What are we changing here? We are changing the new sauce to see, we're testing the new sauce to see if it reduces gas production. What is the dependent variable? Okay, so what is supposed to change because of the new sauce? That would be the production of gas, whether it's less or more. What should Mr. Krabs conclude? Well, Mr. Krabs had 30 of the 50 people, or 60% of the people, reporting that sauce A reduced the production of gas. So I would say, compared to sauce B, it probably works. His conclusion should be that the new sauce actually works. And what do you think the 8 people in group B reported? Why did they feel better? Well, I would say that um, they were just thinking that they got the new sauce, and they kind of fooled themselves into believing that they were feeling better. And this is something that is very common um, in these kinds of studies like this. This is called the placebo effect. Placebo effect. Placebo effect. So all of the rest, there's 3 more of these scenarios: slimatosis and marshmallow muscles, and then the microwave um, miracle. All of these are this kind of very much the same thing. They want you to make your observations, identify the variables, and what's the conclusion. What's your control group? What's your variables? What's the conclusion? Same thing here. We got a hypothesis, a control group, and the variables. Okay, and then they have some data for you to look at there. And anyways, we are going to, you are going to be working on those 3 scenarios. Actually, all 4 of them. So, but we gave you the answers to the first one. So good luck. Have a great day, and those of you that are going out in the woods this weekend, good luck with your deer hunting, and enjoy your long weekend. Bye bye.